Hello, welcome with this session about merging drone images and handheld images. My name is Mark Rietman. I'm a consultant in the reality modeling and mapping team from Bentley System. I'm based in Brisbane, Australia. What we're gonna discuss today is the way how to merge images together to one data set. So quite often users flying with a drone and they often georeference, or you use ground control points to georeference a model, and then they walk around with digital camera, handheld photos, and they're not georeferenced. So now in this session, we're going to show how to merge them and create one model. So let me show you an example from how that looks like as an end result. So for example, this is a drone data set with some objects we wanted to have more detail. And what we do, we capture handheld images, merge the data sets together to get something like this. So this is not uh, one set of images. This is drone and handheld combined to one model. So how are we going to do this? So I discussed the workflow here and then I show it with a live data set. So what we do, we create a base data set. It's normally the drone data set. So we run that in context capture, master, create a really good aerial triangulation, and that's our base model. And then we define common points, which you can see in both data sets. That's important that you see points, what you can see in the handheld block and in the drone block. And we create with an option, we create type points. So in the drone block, we select these points as a type point, and then you export them as a text file with a certain coordinate system. So basically, we're selecting coordinates in that data set before we really process that block. Then we create a new block and we import the handheld images and run an aerial triangulation to see if all the images are stitched. Then that text file will be created by point number 3. We import that, and then when we import that in that handheld block, it becomes control points. We can assign them, run an aerial triangulation, and then what you get is that the handheld block is at the same location as the drone block. So the data sets are referenced together. Then we merge them to one block, and then we create reconstruction and production. So we're gonna go through this in a minute. So we create a project, run aerial triangulation. Uh, we create type points here. We export it to a text file. And then over here, so format, export text file. Create a new block for the handheld dataset, run the AT, import these images, and then assign the ground control points, run a new AT with using ground control points, and then when it's finished, you can merge them and go reconstruction production. So let me show you a data set that I have. So I've got a training data set. This is a drone data set, Phantom 4 captured. And these have a coordinate. So these images has an are georeferenced. Then on that, and I can already show that here, see the quality. So for example, these images, there is a nameplate here. And if you process the data set as a normal drone only, you cannot really read the names on this nameplate. But if you go even in separate with a handheld camera and we want to update the nameplate, so there's not, you need more than one image, so you need a small model. And then you see here, this is a better quality. Let's see. And then we're gonna use these images to get a better resolution, better model of the part of the what a nameplate is. So let's start context capture master. Create a new project and see if I where I'm gonna place it. Over here and give it an merge project. So project is created with an empty block, and let's rename that so we can see which block is what. So let's rename it to let's do drone. Import the images over there. So add photos, drone. And if I go to 3D view, you'll see the images are this the way they capture it, and they are georeferenced. So now I'm gonna run the new area triangulation. So submit area triangulation. This is a standard drone quality from DJI Phantom 4, not RTK. So I use rigid registration. Keep everything standard, submit, and let's start the engine. And so now it's running the AT. What I already can do, I already can import the of and create a block for the handheld. So let's create a new block and rename it. Add the handheld images to it. So what you see, there are only 12 photos and it's not georeferenced. So the 3D view is disabled. So I'm gonna already start pushing an AT to the job queue. So everything standard. And what I prefer to run an AT first to check if all the images are connected. You can skip this if you trust your dataset by adding right away ground control points, but sometimes I think it's just easy to run the AT first, and a small dataset like this goes really fast. So now we have to wait till this AT is finished, and then we can go to the dataset. So what I already can do, I can already view what are common points. So let's go, for example, this image over here. And I need to find 4 points what I have, what is in this dataset, in the handheld set, and also in the drone dataset. So 3 points should be enough to do a ground control point, but I prefer to have 4, at least 4. So if you make a small mistake, it's better to have 4 for correcting it. So common points, for example, I can use a point at the top here in corner of this here. I can point at the right bottom, a point at the left bottom, and maybe a point on the nameplate. Don't do 4 points on the nameplate because then over here and here they can be a little bit off. So try to spread out the points over the project, and that's important when you capture the data, that you think about having common points. So let's go back how far it is here. So the first area triangulation is finished now. You say it's georeferenced. And then you see this one, it just picked up, was waiting in the job queue to be processed. So let's go to 3D view, see the result. So you see the capture, and all looks okay, nice around the fountain. So what I'm gonna do now, I already defined what my 4 common points are. I go to the survey tab, and what I'm gonna do is I'm gonna create 4 tie points first. So you select in the survey point tab, add, and let's call it T1, number 2, and 3 and 4. So number 1, and now I have to find that images in of that point in multiple images. So let's somewhere over here. And what I want to use, this is the nameplate. Is this the nameplate here? I want to use this corner. So I can shift select this point and I can go a little bit back and then the same point. So what you see on the right side, it's now blue, and this is a tie point. And now if I have 2 points, it becomes green now. So now I can use it. It's valid for using, but yeah, I prefer to have a third one to make it a little bit better. So now I can use it. So, and if you select here, you see it's in tie point. Point number 2, there's a point that I want to use over here. Now I select the next one, but what I also can do in this image, I can identify point number 3 already also. I can select here, right mouse, set position to tie point number 3, and then maybe adjust it a little bit and accept. So you don't have to switch between the images if you don't need. Yeah, this makes it a little bit easier. So this, I'm still in number 3 here. So I can, let's finish number 3. Maybe not the best one. Maybe this one. And number 2. Number 2. And then I'm going to use number 4. Okay, the point on this side. So the points are, let me see, to this one. You see they're now spread out over the project, so over the small drone handheld data set. So 1, 2, 3, and 4. And it looks like 3 is, yeah. So that's okay. So what I'm gonna do now, I'm now gonna export them. I want to know the coordinates of these points. So I can now export them because I already have an area triangulation. So these points are now known in coordinates. I select export here. I go to text file, and the trick is work from the top to the bottom. Because the reason is, let's say I want to export a certain coordinate system. And this is MGA 54, so select 54. So now it's selected. So if I export now the tie points here, it goes to a text file with this coordinate system. But if I now change this, I made a mistake, and instead of text file I had here XML file, then the coordinates system changes again. So make sure you work from the top to the bottom, or yeah, now I have to do it again, MGA 54. So export, I can open this folder. So it's normally directly in the project folder. And if I do textpath, text editor, you see the coordinates of these 4 tie points. So this is MGA zone 54 coordinates. So let's close this. Now I'm gonna go to my Handheld block. You see the AT is finished in the meantime. I go 3D view. And then you see over here, the area triangulation is finished, and this is the way I captured it. So I'll walk a little bit around facing inwards, with a little bit bigger area than only the nameplate. I go to the survey tab, and now I'm going to import the text file. So the text file with the coordinates. So I select here, import from text file, common format. It's over here, so it's this file, open. And now it's important that you choose the same coordinate system as the one where you exported in. So MGA zone 54. And now I can assign them. So if I select point number 1, and if I edit it, I see the coordinates and the coordinate system. So point number 1 was over here. That's this point. And there's no photo selected, so let's do it again. Oh. Okay, so first point, and you need to do at least 3 of them. And then, so I got now from 3 images this point selected. So I'll go to point number 2. That's over here. And see if I can. So that line is showing up because we already have an area triangulation. So the software roughly know what this point is, which line it is. Point number 3 was on the nameplate itself. That's this point. And then we have number 4. And because after 3 points, number 4, the software already know where it is. So it's already pointing to that point. You can do somewhere like this. So now I got my 4 points assigned, and now I'm gonna run the new area triangulation by using control points. So submit area triangulation. I use that option rigid. It's not really that accurate, and it's okay for this type of data set. So rigid registration. I keep everything standard. Submit and start processing. And what you will see, if everything goes okay, that the model will be georeferenced. So if the drone block was already, say, georeferenced, and the handheld block without ground control points was saying relative. Now I'm running a new AT, what goes reasonable fast, and it should say that it's georeferenced. And then we can merge the 2 blocks together and go reconstruction and production. So now it says georeferenced. If I check my 3D view, I see the points that marker, it means it's a control point, so it looks okay. Yeah? What I do now is I can select the drone AT block with the handheld AT block and then merge them to a new block. If this merge option is not available, then it mainly, most of the time, one of the blocks is not georeferenced, so it's here, for example. So make sure that they are georeferenced. Merge block, so it creates a new block. You can, if you want, you can rename it. Let's do it drone handheld, for example. If I go now to my 3D view, am I in there? Yeah. What you see that the data set it's together now. But also you see that there's only tie points. The splash option is not available. And the reason is if we merge blocks, we have to select create splash again. We can also do that from the 3D view. So if I go now to my 3D view, you can see better. And what you also see here, because we merged the tie points and block with tie points and with control points, the tie point is that green square. The control point is that marker. So you can see they look really good. They're on top of each other. And what we can do now is reconstruction, 3D reconstruction. Set the spatial framework, make it a little bit smaller. I only want to process the area where I'm interested in, not so much outside it. So do something like this. And it's still too big for one tile for my machine, so I'm gonna do adaptive tiling. Create 2 tiles, and then I submit production. So fountain, for example, and then 3mx file, 90% MGA zone 54 as output, extend, and submit, and start processing. I already have this done, so I can show you the result. So I got a data set. This is drone only, so only the drone data set. So you can see the quality of the nameplate. You see that So this is drone only. If you go here, you can see you cannot really read the nameplate, but for the rest the model looks okay. If I now go to the merge data set, so this after we merged the handheld images in the drone block and merge them and reprocess it. So if you now go here, you see you can read the name plate. And also if you disable the wireframe and texture, you see there are way more triangles here in this area because it's way higher resolution. So you see more triangles here. Okay, so yeah, I hope the workflow was clear. So you get a base data set, you select common points in there as a type point, export it as a coordinate, and use them as a control point in the other, in this case, not georeferenced handheld data set. It's also possible if you have, let's say, two drone data sets and they're not georeferenced together because of the quality of the GPS. This is also a workflow which you can use for that. So just from one of the data sets you take as a base, and so that's why we normally suggest to fly a little bit bigger data set the first that you can use as a base model, and then georeference all the other data sets to that block. Okay, thank you.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.